nuclear reactions. All right, so radioactivity, natural radioactivity is the spontaneous emission of particles or energy from an atomic nucleus as it disintegrates. So disintegrates just means as it dies out over time. Radioactive decay, so this is the natural disintegration or decomposition of a nucleus. Again, disintegration and decomposition just means the breakdown of. So although it's impossible to know when a nucleus will undergo that decay, it is possible to um, deal with the rate of decay for a given material with precision. So based on the material that the nucleus is made of, you can get a more precise calculation for when it may die out. So the two main subatomic particles in the nucleus are the proton and the neutron. So the proton and the neutron are called nucleons. All right, the number of protons is the atomic number, so that determines the which element that atom is. And the number of neutrons varies in isotopes, which are atoms with the same atomic number but different number of neutrons. And then the number of neutrons and protons put together, this is what we call the mass number. So the nature of the nucleus, so the protons and the neutrons are understood to be held together by a nuclear force. So it's a strong fundamental force of attraction that's functionally only at very short distances. So the longer the distance, the less strong that nuclear force would be. Half-life rate. So each radioactive isotope has its own specific rate of nuclear disintegration. So again, that is the rate at which the radioactive isotope dies off. And it depends again on the material. Okay. So the rate is usually described in terms of half-life. So that's the amount of time required for 1/2 of the unstable nuclei to decay. The radiation measurements, radiation is measured by the effects on photographic film. It's also measured by the number of ions that it produces. And it's also measured by the flashes of light produced on a phosphor. So the different units of measurement for radiation is measured at a source in units of Curie, defined as 3.7 times 10 to the 10 power nuclear disintegrations per second. A REM is a measure of radiation that takes into account the biological effectiveness of different types of radiation damage. The natural environment exposes everyone to about 100 to 500 millirems per year. This is called background radiation. So this is more of our natural exposure just to the outdoor environment. Lifestyle and location influence, that is the background radiation received, but the average is 130 millirems per year. Energy and mass are related by Einstein's famous equation of energy is equal to mc squared, where m is the mass, c is the speed of light, and that is squared. So the mass of the nucleus, this is always going to be less than the sum of the masses of the individual particles of which it's made from. So the mass defect of a nucleus is equivalent to the energy released when the nucleus was formed. According to that equation, E is equal to mc squared. So it's a binding energy, so that energy required to break the nucleus apart into individual nucleons. So nuclear fission versus fusion. All right, so more massive nuclei release energy by fission. So this is the splitting to more stable nuclei. So fission is splitting and fusion is combining. So the less massive nuclei release energy by fusion. So that's the joining of less massive nuclei to produce a more stable, more massive nucleus. All right. So nuclear fission, this provides the energy for nuclear power plants as well as atom bomb explosions. Nuclear fusion, this is the energy source of the sun and also other stars in the universe.